All right, so today we're graphing tangent and cotangent. I already started videotaping, or I thought I was videotaping, but I actually didn't hit videotape, so all this is already drawn out and I wasn't actually recording, so it's fine. Anyways, so some major things. Tangent is gonna look like an S shape, kind of, and it starts on your origin. Cotangent looks like a backwards S, so flipped around, kind of mirrored, and your asymptote is what starts on the origin. So if we were to have an origin right here, our asymptote would go through that right away, and we would have cotan graphs in between each asymptote. If my origin were to be here, then if I had a tangent graph, then my graph would go straight through that origin. And it's the opposite way. So this is an S, this is flipped. Amplitude we're now going to call stretch because we don't have a height. It goes up and down forever. So we're stretching it skinnier or fatter depending on what my stretch is. And your period is now pi over b. So just a little formula change. Everything else we find the exact same. Okay, so given this example, let's go ahead and graph. We still need to find everything. So my stretch or my amplitude is still my A in front of my trig function, which is 1. My period is now pi divided by b. So pi divided by b, here's my b. I'll have pi over 3. My interval is still found the same, so I'll still have my period divided by 4. Pi over 3 divided by 4 is going to give me pi over 12. I don't have a vertical shift, and I have a phase shift of positive pi. Okay? So then, if we graph this, we're going to be all the way over to positive pi with intervals of pi over 12. All right. So I'm going to draw my graph like this. So this is going to be pi over 12. This is 2 pi over 12, or pi over 6. 3 pi over 12, or pi over 4. 4 pi over 12, pi over 3. 5 pi over 12. 6 pi over 12, pi over 2. 7 pi over 12. 8 pi over 12, or 2 pi over 3, 9 pi over 12, or 9 pi over 12, 3 pi over 4, 10 pi over 12, 5 pi over 6, 11 pi over 12, and pi. Jeez. All right, almost off the paper there. Anyways, so here's my graph. We'll just do 2 tip marks up, 2 tip marks down. And then same thing, we have to find our new origin. So we're going to do that using the phase shift and the vertical shift. I have no vertical shift, so I didn't move up or down. I have a phase shift of plus pi. So that's where my origin is. Since I have a tangent graph, I am starting my actual graph at that origin. Okay, so I'm going to have a point here. Then I'm going to use my stretch as my slope to go up and to the right. So my stretch is 1, so I'm going to go up 1, and to the right 1. Then I'm also going to go down 1 and to the left 1. And that's going to be one of my graphs, okay? I'm totally off the paper, but I'm going to have vertical asymptotes at the next interval over. So this ended at 11 pi over 12. My next interval, 5 pi over 12, or 5 pi over 6, sorry. I'm going to have an asymptote. Okay, if I could fit one over here, I would also have one over here. Gosh. Okay. Then I continue this. So every 4 intervals, I'm going to have an asymptote. So 1, 2, 3, 4. This is going to be my next asymptote. Okay. In the very middle, so 1 tick mark to the right, 1 tick mark to the left, and then in the middle, that's going to be the center of my next period. Okay, so this was 1 period, this is 1 period. Okay, the very center is my center, and then once again, I'm going to go up and over and down and to the left and connect. I'm fine with you guys just drawing 2 periods just for the sake of example. I'm going to do 1 more. So 1, 2, 3, 4. This is my next asymptote. Plot that point dead in the middle, to the right one, and up, to the left one, and down. Okay, so this is how I graph tangent. My range is negative infinity to infinity. It goes up and down forever. Now, my domain. This is going to be a expression or equation, a set of numbers, and it's always going to look like this. So we're going to have a set of x for all x included in the reals, but x is not equal to blank plus blank times k, where k is a subset of the integers. So that is what your domain is going to read every single time. This first blank is the position of your first asymptote. Asymptote. Okay, so my first asymptote, what I mean by that is the furthest to the left. So it kind of depends on how much you plot. My furthest to the left is pi over 6. Okay, so I'm going to throw pi over 6 in there, because my domain is not equal to that number. My graph is never going to cross that. And then I have to add the distance between each asymptote to get to my next asymptote every single time. So the distance is actually 1, 2, 3, 4 intervals, which is the same as 1 period. So 1 period is pi over 3, which is going to go in the second blank right here. Okay, so if I took pi over 6 and I added pi over 3 to it, I would get to pi over 2. And that's my next asymptote. And this continues k times, where k is a subset of my integers. So integers are 1, 2, 3, counting numbers. So to get from here to here, I multiply it by 2 and I get to my second asymptote. Multiply it by 3, I get to my next asymptote, etc. Okay, so this is the set of numbers, the equation that we write in order to do domain. All right, I already graphed this one and I'm just going to run through it. So having cotan 2x plus pi, once again your asymptote is on your origin and it looks backwards. So my stretch is 1, period is pi over b, so pi over 2. Divided by 4, pi over 8 is my interval. I have a phase shift of negative pi, no vertical shift. My range is always negative infinity to positive infinity. So this is my graph. I labeled my intervals. I went over my phase shift of pi. And at this phase shift, I had a vertical asymptote because I'm graphing cotan. So I had a vertical asymptote here. 1, 2, 3, 4 intervals to the left, I have another vertical asymptote. 1, 2, 3, 4 units, I have another vertical asymptote. So I would go ahead and draw those in first, and then at my center points, draw my center points, and then go up your stretch amount, which in this case was 1, and to the left because it's backwards. So if we go up and to the left, then I have to go down 1 and to the right. And just repeat that 2 times. Okay? Then for domain. So I didn't fill this completely out. Domain is x such that x is a subset of all the reals. Okay? X cannot be equal to my first asymptote. So my first asymptote is just farthest to the left, negative pi. And then the difference between my asymptotes is my period. So 1, 2, 3, 4 intervals is the same thing as 1 period, or pi over 2. Times k, where k is a set of the integers. So this is how we're going to write domain. And here's your homework.